Hey everyone and welcome back to the channel. So, what exactly is P0180? The official definition is fuel temperature sensor circuit malfunction. In simple terms, your car's brain, the engine control module or ECU, has detected a problem with the signal from the fuel temperature sensor. This sensor's job is pretty straightforward. It measures the temperature of the fuel in your tank or fuel rail. Why does fuel temperature even matter? Well, the ECM uses this information for a couple of key reasons. First, it helps calculate fuel density. Colder fuel is denser than warmer fuel, so the ECM adjusts the amount of fuel injected to ensure the perfect air-fuel mixture for optimal performance and efficiency. Second, in some systems, it's used for evaporative emissions testing, helping to prevent fuel vapors from escaping into the atmosphere. When the ECM gets a signal from this sensor that's out of the expected range, either too high, too low, or completely absentee, it triggers the P0180 code and turns on your check engine light. Now, let's talk about the symptoms. Honestly, with a P0180 code, you might not notice any major driving issues. The most obvious symptom is going to be that check engine light staring back at you from the dashboard. However, in some cases, you could experience some subtle performance problems. You might notice slightly reduced fuel economy because the ECM is using a default value for fuel temperature instead of a real-time reading. You could also have some minor hesitation or rough idle, especially when the engine is cold. In more extreme cases, you might even have trouble starting the car, but that's less common. The key takeaway is that the symptoms are often not severe, which can make it tempting to ignore, but you shouldn't. So what causes this code to appear? The culprit is usually one of a few things. The most common cause is simply a faulty fuel temperature sensor. Like any electronic component, these sensors can fail over time. The sensor is often integrated into the fuel pump assembly inside your gas tank, which can make it a bit of a pain to get to. Another very common cause is a wiring issue. The circuit includes the wires running from the sensor back to the ECM. These wires can become frayed, corroded, shorted, or broken. This is especially true for wiring near the fuel tank, which is exposed to the elements. A poor connection at the sensor's electrical connector or at the ECM can also be the problem. A little bit of corrosion or a pin that has backed out can be enough to disrupt the signal. Less commonly, the problem could be with the fuel itself. If you're using a fuel with a very high ethanol content, it can sometimes affect the sensor's readings, especially if the vehicle isn't designed for it, and in rare instances, the problem might not be the sensor or the wiring at all, but the ECM itself. This should always be your last resort after you've ruled out everything else. Alright, let's get to the fun part. How to diagnose and fix it. First, you need a good OBD2 scanner. A basic code reader will tell you the code, but a more advanced scanner that can show live data is your best friend here. Plug it in and look at the live data for the fuel temperature sensor. What reading are you getting? Does it seem reasonable for the ambient temperature? For example, if it's a cool day and the scanner is reading 250 degrees Fahrenheit, you've got a problem. If the reading is stuck at a very low number, like -40 degrees, that also indicates a circuit issue. Your next step is a visual inspection. Get under the car and inspect the wiring harness going to the fuel tank. Look for any obvious signs of damaged chewed wires, melted plastic, or heavy corrosion. Check the connector at the fuel pump assembly if you can access it. Make sure it's clean and securely plugged in. If the visual inspection doesn't reveal anything, it's time to break out the multimeter. You'll want to test the sensor itself. You can do this by checking its resistance. You'll need to find the manufacturer's specifications for what the resistance should be at different temperatures. As the fuel warms up, the resistance should change in a predictable way. If the resistance is infinite, indicating an open circuit, or zero, indicating a short, the sensor is bad. You should also test the wiring. Disconnect the sensor and the ECM. Use your multimeter to check for continuity on the signal and ground wires between the two connectors. You should have good continuity. Then, check for a short to ground or a short to power on the signal wire. If you find any issues here, you'll need to repair or replace the damaged section of the wiring harness. If the sensor tests good and the wiring is intact, the problem could be the ECM. But again, this is rare. Before condemning the ECM, it is a good idea to double-check all your work or even get a second opinion from a professional mechanic. Replacing an ECM is expensive and often requires programming. So, to recap the fix. Most of the time, you'll either be replacing the fuel temperature sensor, which may mean replacing the whole fuel pump module or repairing a damaged wire or connector. That's a wrap on code P0180. It might seem a bit intimidating, especially since it involves the fuel system, but with a logical approach and the right tools, it's a very manageable repair. Remember to always prioritize safety when working around gasoline. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and hit that notification bell so you don't miss our next video. Have you ever dealt with a P0180 code? Share your experience in the comments below. Thanks for watching, and we'll see you in the next one.